There's a stone block sitting on a treeless plateau in Bolivia, 12,800 feet above sea level, and when engineers put a digital scanner on its surface, the readout looks less like ancient rubble and more like a machine part off a factory floor. Flat faces, right angles that barely miss 90 degrees, grooves that run the same depth from one end to the other, and it was carved more than 1,000 years ago, at an altitude where breathing hard just from walking is normal, by people we are told had no metal tools stronger than copper. That contradiction is the reason Puma Punku keeps pulling people back in, year after year, scan after scan. So today we're going to look at what these new digital surveys actually show, what they do not show, and why the real answer to how did they do this is stranger and more human than most of what gets said about this place online. Puma Punku sits on the southern edge of Lake Titicaca, the highest large navigable lake on Earth, as part of the much bigger Tiwanaku archaeological zone. Tiwanaku was not a myth and not a footnote. Between roughly 500 and 1000 CE, it was the center of a state-level society that controlled trade and farming across a huge stretch of the Andean highlands, with a capital that may have held tens of thousands of people. These were the people who built raised agricultural fields that let crops grow in thin mountain air, who moved goods across the Altiplano, and who eventually built the platform we now call Puma Punku as a ceremonial and political showpiece. Nobody serious disputes any of that. What people argue about is the finished work. Puma Punku's platform is built mostly from two stones, red sandstone and a volcanic rock called andesite. Both are hard. Andesite in particular sits well above copper on any hardness scale, which means a copper chisel pressed against andesite is not going to carve it the way a knife carves wood. That single fact is the seed of almost every impossible claim you will find about this site. If the tools are soft and the stone is hard, how do you end up with flat panels, sharp internal corners, and rows of blind holes spaced with what looks like machine shop consistency? It is a fair question. It has been a fair question for over 100 years, ever since the Bolivian engineer Arthur Poznański spent decades measuring these blocks by hand and walked away convinced that something about the site did not fit the timeline he had been given. Poznański's own conclusion, that the site was built around 15,000 years before our era, has not held up. Radiocarbon dating of organic material recovered from the site consistently places construction within the Tiwanaku period, centuries after Poznański's date, not millennia before it. But the observation that started him down that road, the sheer precision of the stonework, never went away. It just kept getting remeasured by better instruments. That brings us to the scans. Over the last several years, researchers working at Puma Punku and across the wider Tiwanaku complex have increasingly turned to structured light scanning, laser scanning, and photogrammetry to document the blocks. Unlike a tape measure or a straight edge, these tools can capture a surface as a dense cloud of coordinates, then compare every point against a perfect mathematical plane or a perfect right angle. The results confirm what generations of visitors noticed with their eyes: faces that stay flat across a meter or more, internal corners on the famous H-blocks that deviate from 90 degrees by only a fraction of a degree, and drilled holes spaced along a groove with almost no variation from one to the next. This is real. It is not an internet exaggeration layered on top of ordinary rubble. When people say the joints look machined, they are responding to something that is actually there in the data, not just something that looks impressive in a photograph with dramatic lighting. The H-blocks are the center of the whole debate, so it's worth being precise about what they are. Seen from above, each one looks roughly like the letter H, a rectangular body with channels, notches, and raised sections cut into it. They were designed to interlock with their neighbors, and in several cases archaeologists have found small copper clamps, poured or fitted into carved slots, that were used to physically bind adjacent blocks together. That detail matters a lot, because it tells us this was never meant to be a solid, fused wall the way we might build one today. It was closer to a kit of parts, precisely cut interlocking stone units, tied together with metal fasteners, that could be assembled, and in principle disassembled, as a structure. Some researchers, including archaeologist Alexei Vranic, who has spent years mapping and trying to digitally reconstruct the platform, have described it in exactly those terms: a kind of ancient prefabricated architecture, where standardized pieces were manufactured somewhere else and brought to the site to be fitted together like components rather than carved in place like a single sculpture. So, if the pieces were meant to be a kit, why does the site look like a debris field instead of a finished building today? Part of the answer is depressingly ordinary. Puma Punku has been rated for building material for centuries. Colonial builders pulled blocks out for churches and foundations. 19th century railroad construction in Bolivia used stones taken directly from the site. Earthquakes, which are not rare in this part of the Andes, have toppled standing sections more than once. What we are looking at today is not the original structure. It is what survived after roughly 1,000 years of scavenging, seismic activity, and simple erosion. That is a big part of why nobody has been able to fully reconstruct the original layout from the surviving pieces. It is not that the geometry is unsolvable. It is that a meaningful fraction of the original kit is simply gone, hauled away long before archaeologists ever got a tape measure or a scanner near the site. Now for the part that actually answers the tool question, because this is where a lot of alternative history content quietly stops talking. Two researchers, Jean-Pierre Pratzen and Stella Nair, spent years doing something almost nobody else bothered to do. They try to actually reproduce Tiwanaku and Inca stonework using only the materials and methods available at the time. Not power tools, not modern abrasives. What they, and other experimental archaeologists working in the same tradition, demonstrated is that andesite and similar hard stone can be shaped using harder hammerstones, things like diorite or other tough river cobbles, in a technique called pecking or pounding. You are not slicing the stone the way a chisel slices wood. You are striking it repeatedly, crushing away small amounts of material with each blow, gradually working a rough block down toward a flat surface. It is slow. It is genuinely difficult. It requires serious skill to keep an entire face consistent instead of gouging it unevenly. But it works, and unfinished blocks left scattered around Tiwanaku quarry sites actually preserve this process in progress, showing surfaces at different stages between rough pounded and fully smoothed. After the rough shaping, final flattening and polishing would have used finer abrasives. Sand and water worked across the surface with a flat stone, the same basic finishing principle Egyptian stoneworkers used on granite half a world away and centuries earlier. None of this required metal tools harder than the stone itself. It required patience, organized labor, and a tradition of craftsmanship passed down and refined over generations, which is exactly the kind of thing a large, stable, state-level society like Tiwanaku had the population and the political structure to sustain. The transport question gets solved the same unglamorous way. Surveys around Puma Punku have identified quarry sites for the raw stone, including sources roughly 10 kilometers away for some material and considerably farther for other blocks, along with graded pathways connecting those quarries to the construction site. That is physical evidence of planned, large-scale logistics. Routes built specifically to move enormous weights across difficult terrain, using ramps, rollers, ropes, and coordinated human labor. The same basic toolkit used to move megaliths at sites on every continent where large stone monuments exist. It is exhausting, dangerous, and genuinely impressive work, especially at an altitude where every hour of physical labor costs more than it would at sea level. But exhausting and impressive is not the same as impossible, and evidence of the roads themselves undercuts the idea that these blocks appeared at the site by some unexplained means. So where does that leave the scans and the title of this video? The interior joints on the H-blocks really are extraordinarily precise, and new digital surveys keep confirming that precision in colder, harder numbers than eyeball estimates ever could. What is not accurate is the leap that goes from "this precision is impressive" to "this precision could not have been achieved by the people who lived here." That leap skips over decades of experimental work showing exactly how hard stone gets shaped with harder stone, skips over the copper clamps that show this was engineered as an assembly system rather than a single continuous carving, and skips over the roads and quarries that explain how multi-ton blocks got from a mountainside to a ceremonial plateau. The honest version of this story is not that ancient people had technology we cannot explain. It is that ancient people had organization, patience, and inherited expertise that we consistently underestimate. Because our instinct is to assume precision requires power tools, when in reality precision has always been possible with hand tools, skilled hands, and enough time. None of that makes Puma Punku less interesting. If anything, it makes it more interesting, because the real story is not a shortcut through unexplained technology. It is a portrait of a highland society that organized quarrying, road building, stone transport, standardized manufacturing, and metal fastening into a single coordinated construction system, at an elevation that punishes every single step of that process. We still do not have the complete picture. Archaeologists have not fully reconstructed the original arrangement of the platform, because too many of the original blocks were removed or destroyed long before serious study began, and every new scan adds more precise data without automatically telling us which piece was originally next to which. There's real, ongoing science happening here. Careful measurement replacing guesswork one dataset at a time. What there is not, at least in the actual archaeological record, is evidence for lost civilizations, advanced ancient machinery, or outside intervention. The people who cut these stones have names we do not know and stories we cannot fully recover. But the stones themselves, once you actually study how they were made instead of how they look in a dramatic photo, tell a very human story. It is a story about what people can achieve with nothing but rock, water, sand, copper, coordinated labor, and generations of accumulated skill, working at an altitude that would leave most of us gasping just to stand still. Puma Punku does not need aliens or a lost prehistoric civilization to be one of the most remarkable engineering achievements of the ancient Americas. It needs exactly what the evidence actually shows: skilled people, a functioning society, and enough time. The scans are not proof of the impossible. They are proof of how good ancient hands really were. And honestly, that is the more impressive story anyway. If you want to see more breakdowns like this, where we take a viral ancient mystery and actually walk through what the evidence supports instead of what makes the best headline, let me know in the comments which site you want covered next.